Hello. Today's problem, we're not going to be talking about Logan and Cassidy. That was on the on yesterday's video lesson, or the previous video lesson. But here we have the Logan and Cassidy problem. I want to use this to help us understand how to do the burger problem that we're going to look at shortly. In the lesson on Logan and Cassidy's work, we didn't use this distance, rate, time table, but I thought this might be a really handy organizing strategy to make the work easier to process, easier to understand. For example, when I look at this information, there's something that I can see that I know in terms of the columns of rate, times, and distance. For example, I know time is 4 hours. That's going to be fixed, not variable, so I could put that into my time column. Rates, I don't know the rates, but I do know a relationship between the two rates of speed, and that is Logan is going slower than Cassidy by 7 kilometers per hour. So that's how I can relate the two variables of their different speeds. And then the relationship is, if I multiply the time times the rate, I get distance. So 4r represents the distance that Cassidy traveled in 4 hours, and 4r minus 28 represents the distance that Logan traveled in 4 hours. That's 7 miles per hour less, hence 28 miles, or kilometers rather, total fewer. Now in this problem, what we did was we said since Cassidy's headed this way and Logan's headed that way, that the distance between them is represented as the hypotenuse of a right triangle, and we use the right triangle to formulate our equation. Today's problem is a little different, but it's related in as much as it's kind of a distance, rate, time problem. Instead of distance, though, we're talking about hamburgers. Hamburgers equals rate times time. So I'm given information about how long it takes these two guys, Calvin and Bonzo. It takes them 12 hours to eat 1,260 hamburgers. We know that there's a relationship between the time it takes Calvin to eat the burgers by himself and the time it takes Bonzo to eat the burgers by himself, and all that information is enough to figure out how long it would take Bonzo to eat the burgers by himself. The way this works out, same thing, we have Calvin, Bonzo, and we have distance, rate, and time, but instead we're using burgers instead of distance. The other thing that makes this different is in the lesson with Logan and Cassidy, we used a right triangle and to find a relationship between the two. Here, we're using the fact that Calvin and Bonzo are combining their burger eating. So here is Calvin and Bonzo's combined rate and their time and their burgers as well. So from the given information, though, I can see in the last problem, Logan and Cassidy, the one thing that was constant was time. 4 hours, 4 hours, 4 hours. That's not true in this case. We know that Bonzo is going to take a little less time than Calvin, so they're not all going to be the same times. But from reading this, I recognize 1,260 is the number of burgers they eat, no matter whether they're eating them alone or together. The other thing I know that in this table that's absolutely certain is the time, 12. The other thing, 12 is the hours that it took for the two, Calvin and Bonzo, to eat the 1,260 burgers. The other thing that I know I'm going to use to fill in my table is it says how long did it take Bonzo to eat 1,200 burgers by himself. So this right here, this Bonzo box, is going to represent the time that it takes, which is the time that I'm looking for. That's the thing I need to solve for, my independent variable. So that's what I put time. And then I know Calvin, if I add 7 hours to Bonzo's time, I get Calvin's time. The other stuff, unknown. I don't know how long it took I don't know how fast Calvin ate, I don't know how fast Bonzo ate, but I do know how fast Calvin and Bonzo ate together. So their combined rate, if there's 12 hours, 1,260 burgers, that's going to be 105 burgers per hour combined. But I don't know if that means Bonzo's eating, like 100 burgers per hour and Calvin 5 burgers per hour, or is it closer to 50 burgers per hour and 52 burgers per hour? I don't know. So I'm going to leave these as unknowns, but combined. Because distance equals rate times time, or burgers equals rate times time, I could actually create 3 equations by multiplying the rate times the time to get the total number of burgers. The third equation can be simplified by dividing both sides by 12 and getting a much smaller, better equation. Smaller numbers, coefficients of 1, that's a plus. If we can do that, that's a good thing. Now I go back and remind myself that it's time that I'm looking for. In all 3 of these equations, there's a C, a B, and a T. Well, this one doesn't have any T in it at all, but time is what I'm looking for. Time is what I want. So if somehow or other I can rearrange or reshuffle these equations to create a new equation that would actually just have time in it. So I take this known fact. Since we have Calvin's rate times the Calvin's time equals 1260, then by dividing both sides by t plus 7, I get Calvin's rate equals 1260 over time plus 7. Bonzo's rate is 1260 over time. I also know that Calvin's rate plus Bonzo's rate is 105 burgers per hour, which means I can do substitution. Oops, that was unintended. Hold on a second here. Alright. So there it is. Basically, this C right here has been replaced with 1260 over t plus 7. This B right here was replaced with 1260 over t. So now I have an equation. There's only t's in it. So if I rewrite the equation, the rest of this is just algebra. I'm going to multiply by the product of the denominators to fraction bust. So on the left-hand side, I distribute t times t plus 7. On the right-hand side, I multiply by t times t plus 7. On the left, I'll divide out common factors. So I'm left with 1260 times t, 1260 times t plus 7, and 105 times t plus 7. At this stage, I should slow down just a second. I recognized from earlier work in this problem that 105 times 12 equals 1260. So I'm going to divide both sides of this equation by 105 so that I get smaller coefficients, better numbers to work with. It's a great strategy. Also notice that I distributed the t squared plus 7t. Boom. The rest of this, again, just algebra. You got to distribute the 12, collect like terms, write the equation in quadratic form, factor, and use the zero product principle to find two solutions. The first one is real, the second one not part of the domain. There's no negative 4 hours to eat burgers, although the first 4 hours could be pretty negative feeling. And then I go back and make sure I answered the question. So I wrote that Bonzo ate the burgers in 21 hours, which is insane. Calvin took 7 hours longer, so it took him 28 hours to do the same thing. And there's your burger problem. Hope you're hungry. Have a great day.